Alright, here I want to show you how you can draw surface development of an oblique cylinder. How you can construct the surface development of an oblique cylinder. An oblique cylinder is a cylinder in which its center axis is inclined at an angle to the horizontal. So if you look at the screen very well, you can see the 4 diagrams on this paper. And if you look at what is written here, this is an oblique cone. This is an oblique cone. The cone, the shape of an oblique cone, or the front elevation of an oblique cone, is always in this form. And what I said about the central axis of the cone or the cylinder, which is oblique, is always inclined at an angle to the horizontal. For example, this is the central axis of this cone, and it is inclined at an angle 60 degrees to the horizontal. And also, this is an oblique cylinder. If you look at the central axis of this cylinder, it is inclined at an angle 60 degrees to the horizontal. So then this one is a right cone and this one is a right cylinder, because we call it a right cone, or we call this a right cylinder because the central axis is inclined at an angle 90 degrees to the horizontal, which is a right angle. So this is an oblique cone, this is an oblique cylinder, this is a right cylinder, and this is a right cone. So as I said, what I want to show you here is how you can construct the surface development of an oblique cylinder. And later we also talk about how you can develop the surface development of an oblique cone. So let's look at that of the cylinder first. If you are watching my video for the first time, you are meeting my video for the first time, you are meeting me for the first time, I really appreciate that. You are welcome to His Grace Tutors, where we teach technical drawing. So if you are a technical drawing student, or you have friends that are technical drawing students, I really appreciate you for sharing my video with your friends, and also you too for watching my video. And don't forget, you need to practice. So as you are watching my videos, you need to sit down and practice on your own so that you can master it. That's the purpose of practicing. And when you subscribe to my YouTube channel, make sure you put on the notification bell so that whenever I upload a new video, you will be notified. So thank you for watching, and let's go and look at how we can construct the surface development of an oblique cylinder. Now, as I've said, that an oblique cylinder is a type of cylinder in which the central axis is inclined at an angle, It can be angle 45, it can be angle 60, it can be angle 30. So whenever they want to give you such a question, they will give you a diagram and you'll be able to understand it as I'm going to explain it here right now. Now, the first that we need to do is that we are going to draw a short vertical line. So draw a short vertical line like this. Then we draw horizontal line. Alright, so let's say the circular base of the cylinder is 60 millimeters in diameter. That means the radius is 30 millimeters. The radius is 30 millimeters. So take a measurement of 30 millimeters with your compass and draw a circle. I would like to use 50 millimeters. I like to use 50 millimeters, not 30. So that means the diameter is 50 millimeters and the radius is 25 millimeters. So I've taken a measurement of 25 millimeters. So you draw a circle like this. So draw a circle. So draw a circle like this. Alright, so we are going to divide this circle into 12 equal parts. So divide the circle into 12 equal parts. So I'm going to pause the video while I do that. Alright, the circle has been divided into 12 equal parts and I've numbered the points on the circle. So the next thing that we are going to do now is to move up a little bit and draw a horizontal line here. So with this horizontal line that you have drawn, so I'm going to project a line from the point on the circumference on the circle. So from point 0, I produce this point. I'll project that line, and also from this point 11, I project the line. So from point 10, I project a vertical line. From point 9, so don't forget that 9 and 3, they are on the same point on the circumference of circle. Likewise 4 and 8, they are on the same point on the circumference of circle. 5 and 7, they are also on the same point on the circumference of the circle. And then we have what? We have 6. So there is it. Now the next thing that I'm going to do is that I'm going to draw the central axis of the oblique cylinder. So central axis, we draw that first. So as I said, that the central axis is going to incline at an angle 60 degrees. I'm using angle 60 degrees. So you take your set square and you set it on the center line here, this middle line here. So you set it, the 60 degree side, you set it here, and you draw an inclined line like this. So this line is inclined at an angle 60 degree to the horizontal line. So from this point here, from this first point here, I will draw a line with that same 60 degree side of my set square. Likewise, this last point here, I will also use the 60 degree side of my set square to draw an inclined line. So then next thing I'm going to do is that, so let's say the height from the center here is 60 millimeters. So the height from the center here is 60 millimeters. I will take a measurement of 60 millimeters. Is it? Then I'm going to draw a horizontal line. So this is going to be horizontal line so that it can be parallel to the base. So next thing I'm going to do here is to make these lines, a thick line. So this line also is a thick line. So this line be a thick line. Likewise, this line will be a thick line. Alright, so that is the oblique cylinder. Then the next thing I'm going to do is that I'm going to number this point. So this point is point 0. So this point is 1, 11. This point is 2, 10. This point is 3, 9. This point is 4, 8. This point is 5, 7. And this point is 6. So what I want to do now, as I said, that I want to show you how to draw the surface development of an oblique cylinder like this. So we have to open it from somewhere, and that point at which we have to open it is known as a seam. So I want to open from this point. So this from this point 6. So I will call this this is seam XX. So that I'm opening from there. So the next thing that we are going to do now is that with my 60 degree set square, I will project this line from point 111. So I will project it up like this. So it goes up like this. Then this also I project this, it goes up. Then so this also, it goes up like this. Then this also will also go up like this. All right, so now the next thing that we are going to do now is that from each of these points on the base of the cylinder, I'm going to draw a line with the 30 degree side of my set square. Why am I using 30 degree side? Is because these lines, they are inclined at an angle 60 degree. So I need to draw a line that will be perpendicular to each of these lines. And for line to be perpendicular to each of this line, I have to use the 30 degree side, because 30 plus 60 will give me 90. So when I use 30 to draw it, it will be at a right angle to each of these points. So what I mean is this. So with the 30-degree side of my set square, you project a line from this point. So project a line from this point like this. Also move it down here, project a line from this point. Here, from here again, you project a line like this. From this point, you project a line. From this point here, project a line. Alright, so from this point, you project a line to this side. So from this point, project a line. Okay, so we also do the same thing around here. So from this point here, from this point, project a line. So from this point here, project a line. From this point, project a line. From here, project a line. Then here also project a line from here. And from here, project a line. And the last one is this, project a line from this point. Alright, so all these lines that we have drawn, I believe you can see the lines. So all these lines that we have drawn. So the next thing that we are going to do is that with the 60-degree side of your set square, just move it to this side a little bit and draw a line at a right angle to these lines like this. Now, after you have done this, the next thing that we are going to do is that we are going to calculate the circumference of this circle. We calculate the circumference of this circle. So, as we have drawn the circle with a radius of 25 millimeters, that means diameter is 50. So, the circumference of the circle is pi d. That is 3.142. 3.142 times 50, and that will give us approximately 157 millimeters. So you take a measurement of 157 millimeters. So we are opening from this point, which is 0.6. So that means we are going to have 6 here at this point. So fix this one at 6. Then from this point here, take a measurement of 157 millimeters. A measurement of 157 millimeters. So this is 150 already. Is 150 already, so I still need 7 millimeters. I still need 7 millimeters. So this is 150, so I need 7 millimeters. So I'll just take a measurement of 7 millimeters in addition to that. So this is 7. Okay, so with that 7, the next thing I'm going to do is to draw a line with 60-degree side of my set square. So draw a line from here. Okay, now after this, I'm going to divide the distance from here to here into 12 equal parts. So this point, as I'm opening from here, I'm going to have 6 on this side, I'm going to have 6 on this side, so I'm going to put 6 here again. Okay, so the next thing that we are going to do is that we are dividing this distance 6x into 12 equal parts. So for me to do that, so from this point, I will, so from this point, we draw an inclined line like this. So I'm going to do the division. Then when I'm done, I will come back and show you the next thing that we are going to do. Alright, so distance 6 has been divided into 12 equal parts. So the next thing I'm going to do is to number this distance 6. So let's start like this. So after this 6, we have 5 and 7 on this point here. After 6 here, we have 5, 7. So I'm going to put 5 here at this point here. I put 5 here, and I'm going to add 7 at this point here. Just follow me. Then I'm going to put 4 here. 4, 8 follows 5, 7, and I'm going to put 8 at this point here. Then next is I have 3. Then I have 9. So I have 3, so I have 9 here. Next I have 4. sorry, next I have what I have 2 and 10. So this is 0.2 and this is 0.10. So next I have is 1 and 11. Then this is 0. So at this point I have 0 at this point. Alright, so having done this, the next thing that we are going to do is that with your 60-degree set square, we are going to draw incline line on each of these points. So a line that will be, a perpendicular line to each of these lines or to these lines. So on each point with your 60-degree set square, so draw a line like this. So draw this line. So move to this point. So you draw a line. Then we'll move to this point. So draw a line here. So move to this point. Draw a line. So move to this point here. So draw a line. So move to this point. So draw a line. So move to this point. Draw a line. Here also. Draw from here. Draw a line. And so draw a line here. And then so draw a line here. Alright, so now with what we have done here, so the next thing that we are going to do is to locate some points, because we are opening from here. So we are opening from 6. So this is on this line. Here we have 0.6 here, and here we also have 0.6 here. So next is 5 and 7. So you follow line 5 and 7. So horizontal line 5, this line 5 and 7 and this line 5 and 7. So they intersect here and they intersect here for 7 here. Next is 4, 8. So you follow the line, follow this line and follow the vertical one. So they intersect here for 4 and also they intersect here for 8. So just follow the way I'm doing it. And for 3 and 9, so they intersect here for 3 and here they intersect here for 9. So just follow the way I'm doing it. Then 2 and 10. So for 2 and 10, so we have this point here of as point of intersection, and for 10 we have this point here as point of intersection. For 1 and 11, we have this point as point of intersection, and we have for 11 we have this point as point of intersection. So for 0, so this is the point of intersection. So we are done with that part. So if we go up here, this is the point for 6. This is the line for 6. That means we have this point for 6 here, and we also have this point for 6 here. So next is 5 and 7. 5 and 7, so we have this point for 5, and then we come here, we have this point for 7. Then this point is for 4, and this point is for 8. Then we have this point for 3, and we have this point for 9. Then we have this point for 2. Then we have this point for 10. So this point is for 1, and this point is for 11. Then we have this point for 0. So all this will be joined together with the use of a French curve. Alright, so I'm going to use my French curve to join this point together. So just look at the way I'm going to join it. Look at the way I'm going to join the point together with the use of a French curve. So I can join these two together first. Then I can join this together like this. Alright, so then I'm going to join this together. Alright, so yeah, I turn to this side. So join this together. So this will be joined together like this. Alright, so the next is join this together. Join this together. Alright, so the next is this side. Connect this together. We are getting to the end. Okay, so we join this together like this. So this goes, then we're going to join this together. So this is joined together like this. Alright, so the next thing that we're going to do is that, so this point, this line, so make it a thick line, and this line, we make it a thick line. Alright, so this is what we are going to get as the surface development of this oblique cylinder. So this is how you can develop an oblique cylinder. Just sit down and practice, do it yourself, and I believe you also get it done. So don't forget, if you have not subscribed to this YouTube channel, subscribe and put on the notification bell so that whenever I upload a new video, you'll be notified. And then don't forget to share my video with your friends who are also technical drawing students. Thank you for listening and thank you for watching. God bless you.